The third factor is induction. For example, compare the following two compounds. Imagine that we have this carboxylic acid and this carboxylic acid. Here we have acetic acid, and here we have trichloroacetic acid. Now, if we wanted to compare these two compounds to each other and ask which of these is more acidic, so we do what we always have to do. We have to draw the conjugate base of each and compare, in each case, the stability of the negative charge. The conjugate base of acetic acid looks like this, O-, and the conjugate base of trichloroacetic acid, also O-, with the 3 chlorine atoms on. Now, if we wanted to compare this conjugate base with this conjugate base to ask which is more stable, so we start with factor number 1. Factor number 1 says what atom is the charge on. Here the charge is on an oxygen atom. Here the charge is on an oxygen atom. So factor number 1 does not give us an answer. So we move on to factor number 2. Factor number 2 was resonance. And in this case we have resonance, O-, but we also have resonance in this case. And therefore, factor number 2 also does not give us any indication as to which of these is a more stable negative charge. So that's why we move on to factor number 3, which is induction. We look at the inductive effects of the chlorine atoms. The chlorine atoms withdraw electron density in the following direction towards them. And they make this carbon atom right here very, very delta plus. Very poor in electron density because the chlorine atoms are withdrawing all of that electron density. When a carbon atom is very low in electron density, delta plus, it is very electronegative. It withdraws electron density from its neighbor, which then in turn withdraws electron density from its neighbor, which stabilizes a developing negative charge there. We have a negative charge here. The overall inductive effect of the chlorine atoms takes that negative charge and spreads it out over the chlorine atoms and makes the negative charge now spread out over a larger volume of space and serves to stabilize the negative charge. Therefore, this conjugate base is more stable because the negative charge is stabilized by an inductive effect which is not present up here. If this conjugate base here is more stable than this conjugate base, that means that this must be the stronger acid. So trichloroacetic acid is more acidic than acetic acid because of the inductive effects of the chlorines which stabilize the negative charge in the conjugate base.